class. Oh, wow, you just took a bite. I'm sorry. Hold on. I'll wait for you.
Yes.
Oh, thank you. Vincent! Nephi? Okay, there we go. All right. So, yes, very large classroom today. Uh, so, make sure everyone's ready. Of the type of indiscriminate that indeterminate that we can do, I'm actually going to stop at these ones here because some of the other ones you really almost never see. So there's some that you'll almost never see, which is going to be these ones over here. These are indeterminate for 1 to infinity, 0 to the 0, or infinity to the 0. So these ones right here, super, they're a pain in the butt. But it's just one of those things for the limits. So they are in the notes if you ever see something crazy like this. You have to ln both sides to actually try to clean them up and then to find the limits of each. But we don't have to do all that. So we're going to do these ones here, and I think this is where I'm going to try and leave you off because this is going to be either 0 times infinity. Yeah. So it is 0 infinity or which ones? It doesn't have the title on the thing. But yeah, 0 times infinity for these parts right here. And then we got infinity minus infinity. But we're not going to do the last couple because those ones are really awkward and almost never come up. So the objectives that we actually have to cover are just these ones to the 0, to the infinity minus infinity. All right, so let's take a look. So whenever you have something like this, we have to rewrite it first, and this is what's not in the notes. And this is kind of one of the things that I don't like about this, but it's just, it happens. So if you have an f times g, okay, if you have a f times g, which is going to give me there we go. So f times g. So whatever it is, we're going to actually try and do it, and it's going to be the limit as x goes to some number c of those. So if we have those two right there, we're going to rewrite them because we need to have it as the indeterminate form. So as the indeterminate form, we're going to kind of make it weird. So I'm going to rewrite it as f over 1 divided by g, or g divided by 1 over f. 1 divided by f. So all the time when I say, hey, we need to multiply that by the reciprocal, yeah, and that's the same thing. So now we're actually making it into the reciprocal, so it's the same as f times g. Okay? So to get the indeterminate, I'm going to start with this concept here. This is my f times g. So my f is x, my g is ln x. So I'm going to rewrite this. I'm going to call this one f and this one g. And to try to simplify this, I look to see which one's the more complicated one. The more complicated one is going to be the one that I put on top. So that's why there was 2 different versions of it. Someone at the door? Oh, okay. So I'm going to rewrite this as g, which is ln x over 1 over x. So now if I do that right here, so now to write it as an indeterminate form, I can go from here. So what is ln going to 0 from the right-hand side? What's that goes to? It's going down, right? If you remember that ln graph, it's going down to negative infinity, right? It has an asymptote at 0, so it goes down to negative infinity. And what about this one right here? As x gets smaller and smaller, 1 divided by very small, smaller and smaller. It doesn't go to 0, because think about it. You have 1 pizza divided by 10 people. Okay? Let's say it like that. And now we want to get that smaller. So each person would get 1/10 of a pizza, right? Now let's do a smaller number. Okay? So I'm going to divide it by 4 now, right? So it's 1 pizza divided by 4 people. That's going to be 0.25. So, okay, is that getting bigger? So let's try that. 1 pizza divided by 2 people. They get 0.5, right? And what's happening as the numbers keep getting smaller? It keeps getting bigger, right? Okay, so 1 person divided by 1 pizza divided by 1 person, I get 1, right? Now, let's try this, okay? Not knocking on any short people here, but 1 pizza divided by half a person. I get 2, right? So as I keep getting smaller, this number ends up getting bigger, right? So as I'm taking 0, the denominator closer to 0, it keeps getting bigger and bigger and bigger. So this is also going to a positive infinity there. So that's what I needed. I need the indeterminate form. So, homie. Yeah. So now we have indeterminate. So from here, this one will work. So I could go ahead and now use L'Hospital's rule, or L'Hopital's rule. So I can do the derivative now from here. What's the derivative of ln x? 1 over x, okay? And on the bottom right here, okay, so now I could rewrite this for the sake of, I could rewrite that x to the negative 1, right? Take the derivative, I get a negative 1 over x squared, because the derivative turns into negative negative x negative 2, like that, right? That's my derivative of x to the negative 1. And I rewrote it like this. So I'm going to multiply by the reciprocal here. So I have fraction over fraction, so I'm going to multiply by the reciprocal. So it's 1 over x times the reciprocal of the bottom, which is a negative x squared over 1. A couple things cancel out, and I end up with just a negative x. Now can I plug in 0? Okay, so as that's getting closer and closer to 0, I get an answer of 0. Does that make sense or no? Bless you, I think. All right, B, same thing. So now I have to look at it as F and G. Which one is more complicated? If this one's F and this one's G, the more complicated one would be the sign, right? So I'm going to put that one on top. So that's going to turn this into sine of 1 over x divided by, what's that going to be? 1 over x. Now, this is an identity. Can anyone tell me what that is? Good job, it is 1. It's it's normally going to look sine of x, but it's going to be sine of x over x. But since this is the same as what's on the bottom, I get 1 there. So, all right. And so this one right here is the other one I'm going to do. This is the infinity minus infinity. Because if I plug in 0, oh dang, come on now. This would give me infinity 1, so infinity 1 over approaching 0 is going to give me infinity minus, okay, that's also approaching 0 here. So sine at 0 is 0, so that's infinity over infinity. Or I'm sorry, 1 over infinity, so that turns into infinity minus infinity. So this is another indeterminate form. And this is, I'm not going to do all of them, where the only ones that we'll see are is like this. Alright, from here, when you see these, do common denominator. Just make this into one problem. Yeah.
Can you explain why?
Plug in 0. So this is 1 over 0 from the right. Okay. So again, this is getting closer and closer to 0, right? This goes back into, as this gets smaller and smaller, this number becomes infinity. Okay. Now, sine, okay, what is sine at 0? 0. It's all the way to the right. Yeah, that's the y value all the way to the right, which is going to be 0. So that's also 0 to the right. Okay, so that's why it turns into, it's not at 0. If this was at 0, this would be undefined. But since this is 0, approaching 0 from the right-hand side, that's why it works like this. So infinity minus infinity. Better? Okay. All right. So now we're going to common denominator. So the common denominator of this would be x sine x, wouldn't it? Okay, because that's both together. So on the bottom, I would have x times sine x. Now, I multiply this way, so that's going to be sine x. I multiply this way, and that's going to give me minus x. Okay, now can we plug in? Now we still have to check it as being the L'Hopital's rule, which is infinity over infinity or 0 over 0. So right here, sine at 0 is 0 minus 0 over anything times 0 is. So this is going to give me 0 over 0. So 0 over 0 is indeterminate, so I could use L'Hopital's rule. So, given that much information, now I could take the derivative of this. The derivative of the top is going to be cosine x minus 1. Derivative of the bottom is going to be a product rule. Product rule, so the derivative of x is going to be 1, so it's going to be 1 sine x plus x cosine x. So there's my product rule for that one. Now can I plug in? Now can I plug in the 0? Cosine at 0 is 1. Okay. 1 minus 1. So sine at 0 is 0. Yeah. Plus 0. So I have indeterminate again. And let me make sure before I go too far into this, because yesterday when I was doing this, I did not pay attention. Yeah, there was no factoring to happen. So did they use second? Yeah, they use second. Alright, so now we're going to second derivative this one. So I'm going to carry it over to a new page. So cosine x minus 1. So that's my first derivative. I ended up getting 0 over 0 again. And let's try second derivative. So derivative of the top is going to be, derivative cosine is negative sine. X, derivative of that goes to 0. Right here, derivative sine is cosine. X. Now this is a product rule for this one, so this is plus the product rule, which is going to be cosine x times 1 plus x negative sine x. Now can I plug in 0? Hopefully I can. So at 0, the limit for this one is going to give me 0, so sine. This one right here is going to be 1 plus, over here, this is going to be 1 plus 0 times sine, so 0 times 0 is 0. 0 over 2. 0 over 2 gives me 0. Okay, so that means that the limit as x approaches 0 from the right is going to be, so back to that problem, 1 over x is 0. And that one I had to take the second derivative of the indeterminate.
How do you know like how far we should go like with like two derivatives like turn it into determinate? Should we just
So if you keep getting indeterminate, okay, as far as I've ever gone is I've had to do the second. If you have to go further than that, then you might have issues. There is, I think there was like one problem one time where you had to take the fourth, but that was like intentionally, specifically, like went out of its way, but it kept simplifying more and more, and like as you ended up getting like 1 or something like that. Yeah, that's as far. I think that was like one of the AP questions a while ago, and I think it even stated that it was going to have indeterminate, and you had to like show it to a certain number. So, yeah, usually at a certain point, don't go much further. All right, so the next problem. These are the other ones that I'm not going to go over because you would ln both sides. These are the ones that they're not part of what is on the course curriculum for this, but still, if you want it, there's the rules on how to do it. But other than that, I just want to finish up. So that means that if we finish today, homework is due Tuesday, right? Yes, Tuesday. All right, make sure you guys all like, share, and subscribe.